right, so hello again, everyone. Good morning, and welcome to today's webinar from the Libelium team that will present grid360. Just a bit of a background on why we're here. EUSIP, an EU-funded project, launched a call to support CIP innovators in validating and promoting their solutions. And after a competitive selection process, we had 9 winners, 9 solutions that were chosen to receive funding and support. One of them is Libelium grid360, so that's why we're here today to see the demonstration of the solution. A couple of housekeeping notes is that the webinar is being recorded and it will be uploaded on our YouTube channel and on the EUSIP Knowledge Hub in the next couple of days. After the presentation and the demo, there will be a feedback session. So we encourage you all to participate and engage with the presenters and provide your feedback. And of course, throughout the presentation and demo, you can also use the chat for any questions. Without further ado, Jose, the floor is yours.
Okay, so let me share the presentation. Okay, I think that you can see, right?
We can see it, yes.
Okay, so again, good morning, everyone. My name is Jose Antonio Cabo, and together with my colleague, John Good, we will have the pleasure of delivering this webinar, which I hope will be of interest to you. First of all, I would like to thank everyone for attending. There has been a great deal of interest from many participants, and it's truly an honor to have the opportunity to present our solution. Secondly, I would also like to thank the EUSIP organization with John and Mariana leading the way for giving us the opportunity to be part of an outstanding group of solutions in the field of critical infrastructure. So let me go ahead to the next slide. A brief overview of the webinar session. First, we will have a short presentation, followed with a live demo, and finally, we will conclude with a Q&A session to gather your feedback. Just a short overview of our company. Libelium is a technology provider focused on data-driven solutions to support better decision-making in addressing the environmental challenges in critical energy and water infrastructures. Our aim is to focus our deep background on environmental projects to help cities, industries, and power companies to operate smarter, to be more sustainable and more efficient. Libelium was founded in 2006 in Zaragoza, Spain, and our technology is present in over 140 countries worldwide. Although our headquarters are in Spain, Libelium has offices in Germany, Saudi Arabia, and Colombia. We have developed cutting-edge technology and solutions based on artificial intelligence, digital twins, and highly accurate devices to deliver precise real-time data on key environmental parameters, allowing organizations to make informed data-driven decisions. As a special mention, I would like to highlight that Libelium was included on the shortlist for the Future Unicorn World 2023 by Digital Europe, which reflects the significant impact of our company in the tech sector. Just some essential points I would like to introduce as a basis. The growing emergence of data centers used to support AI, along with industrial expansion and exponential increase in services relying on electrical power sources, such as electrical vehicles, system digitalization, and connected devices, has led to a quite important annual rise in electricity demand. This demand is expected to grow at a rate of 4% in the coming years. At the same time, we are chasing a decarbonization plan to guide us toward a grid transition. So on one hand, we have a rising demand for electricity, and on the other, we aim to shift from traditional energy sources to sustainable generation based on environmentally friendly technologies such as water, solar, and wind. At the heart of this transition, enabling both demand and generation, is the backbone of our modern society, which is the energy transmission grid. And there is no transition without transmission. So talking about the energy transition and the integration of renewable sources in the power grid, here are some key figures I would like to share before presenting our solution. To be able to integrate more energy from renewable sources, an expansion of the power grid is needed. The International Energy Agency estimates an investment of over 1 billion with B in grid infrastructure by 2030. We talk about amount of energy, we need to go from the 400 gigawatts currently integrated to 2000 gigawatts. Concerning power grid extensions, we need to increase the total length of transmission lines up to 20 to 50% and distribution lines from 20 to 65%. But if we translate these values into something more easily understandable, we need to increase the expansion rate of the grid 20 times at the transmission level and 3 times at distribution level. So the thing is it possible with the existing tools that the companies have? First, let's think about these tools, okay? Taking a deep look into this, we can see the alternative available on power grids. These are the traditional ones shown in this slide. Repowered, conductor replacements, facts, and building new lines. From left to right, we are moving from lower to higher economical, temporal, and environmental impact. And this is where dynamic light rating comes into play, like one of the most cutting-edge technologies, which presents itself as the more economical, sustainable, and immediately implementable alternative. Besides it meets the NOR principle applied in several TSOs, which is network optimization before reinforcement and expansion. So the question is, what's the dynamic line rating? What's DLR? There is no transition without transmission, we mentioned it earlier. And the overhead lines are the assets the power companies use for transmitting energy from generation to consumption. Well, one of the most significant problems that limits the performance of the electrical system is the thermal limit of the wires. The greater the amount of energy it is transporting, the higher the temperature of the conductor is, with a maximum temperature for standard cables typically around 80 to 90 degrees. But this temperature is influenced not only by the amount of energy, but also by the environmental conditions. In cooler conditions, the conductor can cool down, allowing for an increased transmission capacity, which is reduced in scenarios with higher temperatures. The capacity at the end is the maximum capacity of a conductor to transmit energy, taking into account the amount of energy and the environmental conditions. To practically understand how environmental conditions impact the transmission line, let's imagine a capacity improvement bar to represent how the weather conditions impact over this ampacity term. We will call it weather ampacity impact of Y. In the lowest part of the bar, we will find the most unfavorable situation with low wind and high temperature and radiation. As this situation shifts towards on the higher part of the bar with a lower temperature and radiation and more wind, the capacity will progressively increase. From an empirical standpoint, more or less 1 degree decrease results in approximately 1% increase in transmission capacity. A small increase or decrease in solar radiation doesn't have a significant impact. For example, when there is some cloud cover or something like that. But a total absence of the sunlight can lead to a 15 increase in transmission capacity. However, the most crucial factor is wind. 1 meter per second increase in frontal wind speed to the line results in an approximately 40% improvement in transmission capacity, which is particularly significant. This highlights the importance of precise measurement of environmental conditions with minimal range of error. In a world that is increasingly moving toward the digitalization of all processes and the creation of digital twins for future event estimation, we want to emphasize that our solution serves as the perfect link between the digital and the real world. It enables the use of real-time monitoring field data to calibrate and enhance forecast solutions. At this topic, we concretely are talking about an environmental challenge to be able to monitor in a very precisely way the weather conditions to know exactly the capacity of our overhead line in real time, but also to provide what is going to be the capacity in advance so we can help our companies to schedule this energy flow in the best possible way. To face it, these power companies needs to count on top solution and the best partners. And this is where we offer our collaboration with our deep background working in environmental projects. Because the question is why Libelium? Was because we are working with Libelium. We are partnering with a experienced company that have been working with many environmental analysis projects. We have been working for the last 20 years, and we have been participated in more than 80 environmental management projects and deployed more than 550 weather monitoring systems. Most importantly, it involves our participation in the implementation of over 10 projects where we have deployed digital twins to recreate virtual conditions of real environments, helping to provide data-driven solutions. So what's our proposal? The innovation approach proposed by Libelium is a hybrid solution that combines weather digital twin and highly accurate weather stations to provide power companies not only to monitor high precision the meteorological parameters that influence the dynamic line rating calculation, but also to build a digital twin that provides both temporal estimates for the next 96 hours at the points where we have this monitoring system deployed, and spatial estimates at location without an station. This creates a 360-degree view of the asset, including not only weather forecasting over time, but also the spatial forecasting of the power line. What are the outcomes of this solution? This solution unlocks the real potential of the power grid, increasing the capacity by 30% and up to 50%. Besides, it allows to do in a short term. From the very first moment the technology is deployed, we can take advantage of the information and begin the optimization. Concerning investment, DLR presents itself like the cheaper alternative to increase the capacity of the electricity network. And finally, this is a green technology, the best sustainable approach, because we are using the same infrastructure. This is very key. We are not adding new assets. We are not facing big changes in the critical infrastructure. We are unlocking the real power of the grid. Different approaches can be found in the market. Here we present a comparison with other market solutions. If we compare our solution with these other options, such as those that are 100% software-based and positimeter-based or LiDAR-based, we can see that our approach offers some advantage like the next ones. This is that there is no outage required when deploying our system. The TSOs and DSOs don't need to plan how to best avoid interrupting the power service because this is not needed. Another advantage is that because our solution doesn't physically interact with the overhead line, the workers needed to deploy it don't require specialized training. As a result, our solution is easy to install and maintain. Additionally, we work with local wind data, which, as we have seen before, is key to obtaining highly accurate data and enable smarter data-driven decisions. Finally, since our solution is 100% autonomous and self-powered, we can verify everything is working at the moment of the installation. As unique selling points, I would like to highlight the following ones. Our innovative approach could combine the hyperlocal data and digital twins, enables greater accuracy in weather forecasting 60% better than numerical models. This improvement is achieved through the calibration of these models using machine learning, leveraging historical data collected in the field. Thanks to the precise measurement of the environmental conditions, our model can provide information for an early detection service for adverse local events. This is made possible through an API and other modules that make a seamless integration with third parties. Regarding operation, we can highlight the next features, like the anti-tampering model, which detects when a sensor is disconnected and sends an alert. Reallocation of devices is very simple due to the system ease of installation and minimal impact on infrastructure. This also reduces the time required to exploit information, allowing for immediate usage for the very first minute. Thanks to the granular design of the solution, the same measurements can be used to make estimations on parallel lines. And lastly, not less important, the system includes a battery estimation model that makes minor adjustments to the measurements frequency based on the battery's status. We have been talking about accuracy, so to demonstrate this accuracy of the forecast provided by our solution, we conducted a comparative study between a solution based on numerical models, which is the green line on the graphs, our solution, which is the red line, and the actual measurements obtained from more than 20 stations deployed around Madrid. This is the blue line. The study focused particularly on the months of March and May, as these months recorded the highest wind activity. In the graphs, we can see the R-squared values are the same across these different methods. However, it is clear that the mean absolute error is significantly better for our solution. In this slide, we can see one station where it's clear that our model provides predictions that are more closely aligned with the actual conditions observed at the location. When applying estimates from numerical models, we may end up with values that are significantly higher than those measured locally. If the company were to use these inflated values, it could potentially damage the infrastructure. In this slide, we can see another location. We conducted this study and we compare our solution results with numerical models, knowing and seeing a clearly significant improvement in the accuracy. If we extend the analysis to the total 23 locations where we have deployed the weather station, we can observe how the improvement is consistently visible across all forecasts. Now, on the left, we can see a table where we statistically compare the graphs generated by our system with those generated through numerical models. To facilitate the comparison, we have defined an improvement index, which can be seen in the last column. This index measures the percentage improvement of one graph over the other. As shown, our forecasts achieve an average improvement of 60% over numerical estimations, reaching a maximum of 80%, which represent a significant enhancement. These studies highlight what every power company have engaged with already understand. Hyperlocal measurements improves forecast accuracy. This, in turn, helps reduce the safety margin actually and traditionally applied when implementing line rating, ultimately allowing for a significant increase in the amount of energy that can be safely transmitted, ensuring the infrastructure can handle it without any issues. As the final part of the presentation before the demo leave, we would like to share our success story with Red Eléctrica, with the Spanish TSO. We have been working with them for the past 4 years, helping them implement DLR on 11 of their lines. Red Eléctrica conducted tests with various solutions and chose ours as it met all the demanding requirements that needed to be from a partner to bring the project to life. Key highlights included interoperability, security, and reliability. The scope of the project involves the deployment of over 170 meteorological monitoring systems to collect data from more than 500 kilometers of overhead lines, as well as the on-premise deployment of the digital twin. As a result of this project, the company estimates that the capacity of the monitoring lines will increase by more than 200 gigawatts, which corresponds to the electricity consumption of a city with over 64,000 households. Additionally, to the implementation of this project, it is estimated that more than 50,000 of CO2 emissions will be saved by fully using the capacity of the lines and avoiding the need to deploy new lines to increase the capacity. Now I will hand over control to my colleague John, who will coordinate the Q&A session.
Okay. Good morning, everybody, and many thanks for joining us today. My name is John Wood. I work with Jose Antonio in the global sales of this solution, which really is addressing problems that or challenges that are faced globally by all energy supply organizations. So, apart from telling you about what this solution is and what it consists of, this is a great opportunity for us to find out more about you, about the audience, about your motivations in this area. And also, as we're the providers of the technology, we have complete control of the technology. We've included a section as well where you can perhaps give us some pointers as to what you think could be included additionally, etc. Okay, because we strive to adapt our systems and our solutions as much as possible to the market and to solving the problems that the market faces. So if we're going to do a little Mentimeter here, yeah, there it is. Okay, the code. So we can put that in the chat as well. Okay, we've got a QR code that will take you in. So if anybody has any problems, I think, let's see, what is it? 44001530. Okay, So let's proceed with this. I really appreciate, by the way, your participation here. So it's very valuable to us. So the first question really is concerning yourselves. The best description of what you do professionally, whether you're a professional involved in a TSO, in transmission, or in distribution, whether you work on the regulatory side, a regulatory or policy expert, whether you're in academia, provide some kind of professional service, consultancy, etc., whether you're in an integrator, an integration firm, whether you are a provider of technology or software, or finally, whether you are a business owner or a consultant. So if you can just let us know where you're coming from as a professional. We'll just leave that for a minute or so. Okay. I think we can maybe move on. Secondly, what's the main challenge your company faces when in managing overhead power transmission lines, whether it's increasing the capacity of those lines, monitoring the sag, addressing bottlenecks in capacity, network bottlenecks, whether it's the issue of generation curtailments, not being able to contribute your energy to the main power grid, or whether there's some other motivation for or challenge, if you like, when in managing your overhead lines. Okay, if it's other, we have a little bit at the end where you free input, where you can perhaps just add a sentence there with regards to what is your challenge. Okay. Okay, the majority there are looking at the issue of basically bottlenecks in capacity, solving those issues. Okay, we can move on, José Antonio. Whether your company or the company that you're collaborating with, because we're aware that there are some participants who are not necessarily from transmission from energy companies, whether you're planning to increase capacity or whether you're planning to improve the efficiency of the current lines. Okay, fairly even split there at the moment. Okay, more interested in increasing capacity, although there is a demand, obviously, for increasing the efficiency of the current lines. Okay, so if we could move on. So are you planning also, as many companies are, to increase the share of energy sourced from renewables? Or whether you're relying traditionally on traditional sources of power? Again, if you're not involved, or if you don't work for TSO or DSO, please put down what the best knowledge of the TSO or DSO that you collaborate with, or that's in your area or your country. Okay, obviously there renewables is you know, it's a global tendency to try to shift towards renewable power. Okay, next one. So regarding your overhead lines, are they being used at their maximum, or do you have a margin of error for operational security? We have encountered some places where actually overhead lines are already being used at their maximum capacity. So this is a question regarding whether it's you're below 50% of their capacity, perhaps below 75%, or whether they're at maximum capacity. So if you can give your best idea on that, it will be useful to know. If the question's not clear for some reason, perhaps you could either let us know or verbally or via the chat. Okay, we'll move on from this one. How do you currently apply ratings to overhead lines? So whether you apply ratings that are static, seasonal, or whether you're using some kind of adjustment, dynamically or ambient adjust ratings, etc. Okay, so seasonal ratings being used, not so much dynamic ratings. Okay, we can move on from that. Are you using right? We have a blended approach. Okay, that's good. Good to know. We'll modify the questionnaire. So if you're currently using tools, they could be tools like GET tools or topology optimization tools, etc., to optimize energy transmission in some way through your lines. Okay, we can move on. So have you been able to determine the percentage of time that dynamic line rating would improve your rating? Have you been able to see whether... Sorry, please, somebody wants to speak. Or maybe it was accidental. So do you know whether dynamic line rating would be more than 80% of the time it would improve the current rating, more than 50%, whether you don't even track this KPI or whether it's not really of interest to you? Okay. So again, that shows that there's a good percentage of time that DLR would actually increase and produce a good result there. Okay, next question. Are you using weather forecasting to improve or better plan your energy transmission? So the parameters that Jose Antonio was talking about, wind, temperature, solar energy, whether you're actually using those parameters to better plan, and whether they are in-house or external. Okay, more external than in-house, but it's being used. So another question, whether in your organization, these types of investments, obviously there's some investment required in improvement, whether you normally undertake those via CapEx or OpEx, or whether that's indifferent really, whether CapEx or OpEx, or whether you have, again, some kind of blended approach there. Okay. All right, so not a strong tendency towards one or the other there. Okay. We'll move on. And would you be willing, or do you, the organization that you're aware of, would they be willing to really to trial and test this type of solution to see whether it can improve the performance of your grid? So the answers here are, you know, whether you're currently testing that, and we see that you've seen that it's actually working well. Whether you're testing and perhaps you're looking to improve those results. Perhaps the results you've obtained from your tests are not going as well, whether you'd like to. Etc. Okay, whether or even if you don't see that as an advantage. Yeah, we can obviously take this conversation offline too. I would say, with regards to this question, I would say both, really. Both or either. Okay, I'm getting asked in the chat about DLR in general or a weather-only based solution. Okay. Okay, we can move on. Right, this is more of an open response. Okay, from what you've seen of the tests and the functionalities, are there features or functionalities that would make the solution that we propose interesting or in some way very important, essential for your organization? So if there's something that you've seen there that you think of additional to those that you've seen that would make grid360, that the solution we propose, interesting or essential for your organization? Again, we don't have all day to do this, I realize, but if there's anything that that occurs to you, then I'd appreciate that. We could put that in there. Again, we can also take this response after via email or via a call. Okay, so this is really to try and get the best idea of what you see as important. Okay, some interesting answers there. Digital security, which is an integral part of this solution, because it is a critical infrastructure. So the communications are secured. Cost is always important. We understand that. Integration, of course, with your current systems. Again, as the providers of the software solution, this is something that we do all the time. Something it's really an integral part of what we do is to integrate our solutions with the customer solutions. And the implementation can be via SaaS or by an on-premise solution integrating with what you have already. Okay, we can move on. And finally, if you can give us an idea of the impression of what you've seen so far, whether you find this of interest and what you think can be improved there, what you've seen. Perhaps you need to know more. And perhaps a little difficult to answer in real time, but we're very interested. Again, this is a kind of a to and fro, a dialogue with the market. So again, as we have full control of the solution, we're very interested in your feedback of what you've seen. Okay, again, you can reply to this if you like on reflection after, and we're very interested to know what you think there. Okay, this is clearly one we should probably take to an offline type of interaction. Okay,
Yes,
but anyway, many thanks for participating in this to get this feedback.
Thank you very much.
Okay, I'll hand back over.
Thank you very much, John, and thank you, José Antonio, for the presentation. It was really interesting. We are running a bit out of time, but if anyone has any question, I'm sure we can stay for 1 or 2 more minutes. If not, we can wrap this up. We will send a follow-up email with the Mentimeter link. So in case, as John said, if you like to think about some questions, you will have the opportunity to reply after the webinar. Okay, so if there are no further comments, thanks again to José Antonio, John, and the whole Libelium team. And of course, thank you to everyone that attended. We will follow up with the recording and the Mentimeter link. So thank you all very much. Have a nice rest of the day.
Thank you.
Thank you so much. Thank you.
Thank you.
Behind the change, beyond the challenge.